So for those of you who don't know me, I've been a network engineer for about 30 years. The gray hairs are starting to show. Started back in the days of Coax, ArcNet, and Novell Netware. Novell Netware 2.10, where you had to compile the operating system with floppies. You didn't have dynamically loaded drivers. So I've pretty much cut my teeth on just about everything in the world of networking. One of the big frustrations I found is as I went from company to company, and I'm sure you guys have had the same sort of problem, is you come into the new company and say, okay, I need to know what's going on. I need to know what's working, what's broken. And so you start setting up your environment. And your environment is you're going to configure monitoring software. You're going to be configuring your syslog. You're going to configure information to be brought back to you so that you can have an understanding of what does this network entail. Now, the problem is that this process for every one of us ends up taking a long time because you're going out saying, okay, I just discovered that I have a Nexus switch over here and I need to download some MIBs to find out what can we get off of this Nexus switch. Then you find out, okay, I've got some NetFlow I want off of these devices, I want this type, and so you're building and building and building and building. And many times you're building with separate solutions. You're building with one solution for monitoring, one solution for log file, syslog collection, that sort of stuff, another solution for NetFlow, and each of these solutions take individual care and attention to configure. And so I looked at this and said, there's so much building, so much configuring that needs to be done. What's missing? What's missing is automation. Is the ability to plop down and within minutes be able to say, okay, I have all of this information automatically brought back to me, and I'm told what any seasoned network engineer would want to know about the network so that you can solve problems. And so that's where I felt there was something really missing, because the amount of building and manual configuration that was required in the industry for most of the stuff was just too much. It's kind of like the shoemaker's kids go barefoot. You never get the visibility into the network that you want, because you figure if I could just have a week solid, I could get the right pieces of information brought back into my tool, and then you'd put your thinking cap on and say, okay, I need to analyze what's going on to be able to say this information correlated with that information, correlated with that information, put it all together, and you're going to say, due to my years of experience, here's what's actually going on. We've got a layer 2 circuit that's flapping, it's causing a spanning tree reset, here's where the problem's happening, our access point is now the root on that spanning tree domain. I know what's going on, I can get the problem solved. But you have to piece that together with specific knowledge. That's where I figured there was a real big gap in the fact that if you had a solution that was rapidly deployed, that brought back all that information in an automated way and told you, here's what all of these things mean together, and give you a plain English answer, you could get a bunch of problems solved the first day. So I'm going to go through a very short presentation of where we are, what we do, how we're different than other solutions that are out there. Then I'll go into a demo of the solution. So starting off, most companies, just like what I said, they'll get their network monitoring software, they'll configure it to monitor their switches, routers, firewalls for availability, uptime. They'll monitor key links in the environment to make sure that they're online and what their usage is. That's usually as far as most folks go with their monitoring software. The next thing they do is they dive into NetFlow and they start collecting flows from around the environment. Anywhere you have a demarcation point where you're going out to the internet or you're going across a WAN circuit, you're going to want to collect that information. Next thing, you're going to set up syslog and say, I need to have that log file information brought back so I can know what are these devices complaining about. So this is really as far as most companies go, because most of their day, they have to spend time saying, hey, we got a new office opening up, we have SD-WAN, we have new technology we have to deploy, so this is as far as many companies get. They just don't get any further. So, and I forgot, they'll also set up some APM to be able to monitor and measure for SLAs. So that results in limited visibility into what's going on. You have some information on some switches, some routers, some links in the environment, but the big problem is that if something happens and it doesn't show up here, you're not going to know what's going on, and you have to resort to manual troubleshoot the problem. The worst thing is, and I think all of us have fought this, is the problem is transient. User comes up to you and says, hey, everything's fine now, but 20 minutes ago, I had a really bad VoIP phone call. What happened? Well, if it's not happening now, it's going to be real hard to be able to see what happened then that caused that problem. And so many times, You have to tell the user, gee, sorry, I'll research it, I'll see what I can do. Maybe the next time it happens, I'll catch it in the act. That just tells your user that it's going to happen again, more likely again, again, and again before you actually get to the root cause. So this was frustrating to me, and I figured there needed to be a better way to solve these sorts of problems. So the troubleshooting conundrum is that monitoring software is great at telling you about the state of the environment right now. But it's not so good at being able to help tell what happened in the past with enough depth of information to answer the question. You're usually left saying, gee, if I only knew what these error counters were 2 hours ago, if I only knew what the state of spanning tree was 3 hours ago. If you had that sort of knowledge, you could put the pieces together and say, here's a point in time of the network of all of these conditions to be able to solve the problem. So really what you really want to know is when, where, and why did an event occur in the network? So what organizations tend to be still missing, and this is really the challenging part, is these sort of problems. All of these problems are missed by monitoring software. You could have a duplex mismatch and most monitoring software packages wouldn't even be aware of it. You can have a cabling fault. You can have packets dropped out of a high priority queue. And if the queues aren't picked up or manually configured to be able to pull the queuing information, you're going to be blind to that. So being able to see all of these sort of problems and have these sort of plain English answers was really, this is what we aimed for in creating a solution, because this is what network folks are fighting on a day-to-day basis. So what do you need to get that? You need a lot more information. Not just a few error counters on a few interfaces. You need all of the error counters on all of the interfaces. Now you have, whether Cisco or Extreme, or you have, whatever vendor of switches and routers, HPE, they have a ton of information trapped up inside those devices. If you had an automatic way of scooping up all of that intelligence and bringing it back, imagine the things that you could learn about your network. And so that's really what we figured, is that your switches and routers know what's working and know what's broken. If you could just have them automatically interrogated and tell you what's going on, you could solve the problems. So we figure far more information, a high degree of automation to make it so that this can be done. That means that you're not spending weeks or months trying to configure a solution to be able to collect the information. There's automation where it goes out and says, oh, we just found a Nexus switch. We know how to talk to Nexus. Let's pull the specific things that that Nexus supports, bring it back so that we now know what it knows. Oh, we found an HPE switch. Great. We know how to pull that stuff and bring that information back and say, here's what it knows. So no matter what make, model, manufacturer, we're going to be able to scoop up that information and say, this is what your network knows. The next thing, though, is to have some automatic correlation. What I talked about before of saying, gee, I have this piece of information from this tool, this piece from this tool, this piece, and I have to manually put it together and say, I'm going to use my smarts to do that, means you're the only person in the organization that knows how to do that. That means you're going to get a 3 a.m. phone call because you're the only person that knows how to do that. Avoiding that means having a solution be able to automatically string those clues together and say, here's what's actually going on. And that way, you can even have help desk level people say, hey, this is what this looks like. They can confirm it and say, yeah, there's a bad cable going on here. Let's go out and swap the cable and find, hey, this is a Cat3 patch cord. This should have been thrown away decades ago. So other things, though, is organizations want proactive analysis. They want to be able to say, tell me about the problems in this environment so I can go fix them today before a user has a problem. If you think about it, your switches and routers have that information already. Those error counters are tripping up, dropping packets, buffering packets, having issues, and yet your monitoring software isn't collecting that stuff. But if you knew where those packets were being buffered, anywhere in the network, if you knew where they were being dropped, anywhere in the network, you could solve the problem proactively before the user actually has an issue. Now, by collecting far more information than any other product, we're able to do some interesting things, like be able to predict things that are going to happen on the network. What we've learned about some of the error counters and some of the information that we're bringing back, with the ability to analyze all this and say, well, this is what your network is starting to do. You need to be on top of this. We're going to give you a leading indicator to say, this is what's going to happen down the road. So this is kind of the holy grail of what people want to know about their network. Because again, your network equipment knows all of this stuff. The The reason it knows this stuff is when something goes wrong and your monitoring system doesn't tell you, you log in. You use the CLI or the GUI to collect the additional information that you need, and that's what we're looking to eliminate. You don't have to log into a CLI. You don't have to go into a web UI of 6 different products and say, what does this mean, what does this mean, and do that correlation, because this has been automated. So this is what we call total network visibility. That means one deployment is able to collect information on every link of the infrastructure. You guys are responsible for every single link. You ought to have visibility to match. That way, if a user complains about a problem, you're going to be able to say, yeah, I realize that the problem is actually with your individual port. Your phone is on the wrong VLAN, and therefore you're not getting QoS on it. I can fix that. Many times people just don't know what's going on even on user ports, but since you guys are responsible, you ought to know what's going on. So with one deployment, able to collect information on the entire infrastructure, we're also able to go far deeper than any other monitoring package by collecting more information. So what TotalView does is we're collecting 19 error counters of information. That's all of the FCS errors, alignment errors, runt packets, giant packets, even collision counters, that all of those error counters, your monitoring software is going to say, yep, network's healthy, because we're not looking at those ports and we're not looking at those error counters. This is the missing information that when people say, hey, the network's slow and we're having a bunch of retries, or the network is glitching and I'm having call quality issues. This is the missing information that your switches and routers know that your monitoring software doesn't. We figure by automating this, you're going to get all of this visibility. Second thing is we put a heuristics engine on top of this. It analyzes all those error counters to give you a plain English prescription. That way, again, you can push this stuff down to the help desk and you're not getting those 2 a.m. phone calls. It's a cabling fault. Go out and look to see what's plugged into Finance 2 switch interface 3 and find out, oh yeah, somebody's been backing their desk chair over this Ethernet station cord 5 times a day. Yeah, that's going to cause packet loss because we're going to have a bunch of FCS errors and no alignment errors and be able to have that plain English answer. The next thing is we're collecting this information every 5 minutes. That way, a trend and a baseline gets established. It also means that if you want to go back and say, what happened 20 minutes ago when that user had a call quality problem? You're going to be able to look back and say, 20 minutes ago, this is what the problem was, and have enough depth of information to be able to say, it was this cabling fault. It was this VLAN tagging issue. It was a jumbo frame misconfiguration. You're going to be able to see what those error counters tell you at that point in time. Now, to further make troubleshooting easy, we decided to build in path mapping. And so what path mapping allows you to do is be able to see every involved link, switch, and router used between a pair of IP addresses. So if you put in the IP address of this phone and put in the IP address of this phone, it's going to end up looking at the routing tables, bridge tables, ARP cache, spanning tree, put that all together, and be able to say, here is every link, every switch, every router used to connect them. And we're going to show that information over time. That way, you can go back and say, oh, 12:01 p.m. at noon when this user complained about a problem, not only were we dropping some packets out of the high priority queue here, we also had some carrier sense errors here. So there are 2 problems going on at the same time. That allows you to solve those really difficult to solve problems where you say, hey, we think we found the problem. Nope, you only solved half the problem.
And you'll see the QoS markings the whole way through as that traffic goes from hop to hop?
You're not going to see the markings, but you're going to see how the queues handled the packets with those markings.
Okay.
We have another way of actually showing how far the markings get, so we have the ability to do that as well.
Do you have any examples of what the interface counters and statistics would look like and exactly what that heuristic engine would show in plain English?
Yep.
We're just kind of curious how it translates it.
Yep, yeah, actually I'll get right into that.
Great.
So we have, effectively we have the heuristics engine, the plain English answer, and we have the RFC information that back that up so that all of that is together so that you can say, okay, this is what this means, this is the reference to it, this is the plain English answer, this is how that answer was arrived. So it turns into a bit of a teaching tool for more junior level engineers because they're told this is how you solve that problem. So I'll get into that as part of the demo.
Great.
And sorry, one question for you as well. How are you doing the collection? Are you going to get into that a little later on?
Yes, actually there's 2 clicks. You're 2 clicks away from that.
One last question. The 5-minute stat, you keep them for how long?
You can do, the default is 13 months.
Okay.
You can cut that down if you say, I don't care about 2 months ago and I want a smaller database. You can go larger if you have no concerns about
Do
distance.
you aggregate them after kind of average them down to keep them longer, or after 30 months?
So we do aggregate it, but you don't have to if you don't want to. So we've had some customers say, I want every single poll and I want to keep it forever and I have gobs of disk space. It's like, okay, your choice. So it's up to you.
Since you monitor every 5 minutes, how do you handle microbursts?
So microbursts, it's a very interesting question. That actually shows up in a different way. So I'm going to take a very small sidetrack and answer your question. So you're going to have a link that's, let's say, a gig link that shows 2% overall utilization, very low utilization. Most people would say, hey, in a 5-minute polling, there's no concerns about overutilization there. But during that 5-second or 10-second period where you had a microburst link flood that flooded that link and dropped a bunch of packets, we're going to actually show the buffered packets and say, hey, your buffer usage went really high on this interface, and then you started dropping packets. So in a certain sense, we have all of the signs of being able to say you have a microburst when other products just don't, because we're looking at the error counters, because we can tell you're buffering on this interface, and now you're dropping because you ran out of buffers.
Now, mainly we've been describing interfaces and drops and errors and things like that. What about if a routing protocol peering relationship goes down? Do you catch that as well?
So when you have peering and you have multi-links and one goes down, or you
I have two BGP. I have a BGP session up, and for some reason it goes down. Does that somehow roll up in your?
So in one sense, I'm going to say, as much as the BGP is layer 3, I'm going to say that's more of an application layer monitor of the BGP communications. So in that sense, I'm going to say we don't do the application monitoring of that. If there was syslog generated off of that, we could pull that and be able to say, hey, not only did we lose this link, and we have the syslog that we can combine and say, hey, these are the things that happened at the same time. So we can do that level of correlation, but we're not doing the APM of the BGP, which is, I think, what you're asking.
Exactly.
Okay.
Thank you.
Right, and how does the root cause analysis work when you have ECMP?
When you have which?
ECMP in a network, like you have equal cost multipath. It's a common problem when you do root cause analysis because you don't really know which link.
Yeah, in one sense, because we're doing this over time, we're going to have the route tables to be able to determine what the route paths were. If they're equal cost tables, then we have to choose just one route. We're not going to be able to show the equal cost part. That is something that we're investigating for the future. We haven't had a lot of people push for that yet, so it's something that I think is coming and that we should consider in the future. But right now, it's just going to show as this is the path that the packets will take right now. Okay, other things we've added, automatic interactive network diagramming. This was something that we felt that a lot of folks, they end up coming into a network and they say, I don't understand what's going on here. I don't understand the layout of the network, how things are connected. And we figured, we have all that information. Why don't we just put it together and create a diagram? So I know there are other solutions to create diagrams, but in a certain sense, I think we're a far simpler solution because it's one deployment, it's going to automatically collect the information, and it's going to do double duty because it's doing your diagramming and all of these other things like telling you, here's where you're losing packets, here's why you're dropping packets, here's where you're buffering or having QoS issues, so it's all of these other things and having the diagramming. And I'll show you the diagramming soon. We also have a built-in event correlation engine. That way we can splice together all of those clues together to say, hey, we're seeing this from this data source, this from this data source, put that together to be able to say, here's what's actually going on. Other things. The way we looked at the market, we figured there's a lot of companies out there that seem to be, anytime you get them on the phone, the first thing they say is, cut me a check. And honestly, we're geeks, we're engineers. We wanted to solve more problems and figure, don't make this difficult to deal with. So we figured, give you license unlimited cloud service, SD-WAN, SIP trunk, call simulation, NetFlow collection, everything you need to solve problems because these are all data sources for us. The more data sources we have, the more intelligence we're able to parse together and say, based upon these clues, here's what's actually going on. And then the last thing is be able to predict things. And again, I'll show that as part of the demo. So with all of this tends to be a pretty tall bill to be able to set for just about any product, and we figured, let's make this real easy to deploy. A lot of companies would look at this and say, hey, you have to deploy a database server, have to deploy a web server, maybe an app server, so there's a couple of servers. Maybe it doesn't run real well in a virtual environment, and they've kind of crammed it into saying, yeah, you give us 24 processors and 36 gigs of RAM, we can run. Okay, we decided no bloatware. People don't like that. It just increases the cost. So our solution is actually very rapidly deployed and auto-configures. What I mean by rapidly deployed, our installer is 50 megabytes. That's the entire package. This is all coded in C, so it's highly efficient on whatever box you put us on. We actually have some very large networks, I can't mention the names, but some very large networks that we monitor with a single deployment, and that C code does it, and you don't need to have multiple database servers, you don't need to have a whole string of systems that you're having to support. If you think about it, every database server, every other system just means the complexity goes up so that when you need to do an upgrade, you're like, well, we need to upgrade the database server, we need to upgrade the app server, the web servers, make sure it all talks to each other. And I just figure that's a whole lot of fuss and cost that a lot of companies don't even recognize when they end up purchasing a solution.
What database are you using then?
SQLite. So if you guys are familiar with what SQLite is, it's a database that is compiled directly into an application. So this is compiled directly into our service so that it's one service. There's no umbilical, no ODBC connection you have to worry about, so there's a lot of performance you get out of it. And because it's compiled C, talking to compiled C, again, far more performance. The other thing is, because it's compiled directly into the application, there's no maintenance you have to worry about. There's no, hey, is the database server running? is that separate service doing okay? Is the socket listening? Nothing you have to worry about because it's part of the application. So it simplifies everything and just makes maintenance a lot easier. That was another frustration I had as a network engineer is, great, I get this new tool and I'd realize how much care and feeding does this tool need? A whole bunch. Well, wait a minute, that's stealing from my time. It's supposed to be buying my time back from the troubleshooting side, but it's now stealing time. So our whole mantra is make something that works and doesn't take your time so that you can say, this is taking, let's say, 30 minutes a month worth of maintenance time to maintain the solution versus many hours for other solutions. And so that just reduces the overall cost of the solution. So light touch on the network. I want to talk about that just a little bit. A lot of people might be thinking, gee, if you're sucking far more data, these 19 error counters, routing tables, bridge tables, ARP cache, spanning tree, all of that stuff on an automated basis, isn't this going to saturate the network? No. If you put a sniffer on the back end of our product, we've done a very elegant job of designing our packets so that we're doing multiple OIDs per fetch. We're also using get bulk in sensible manners. So there's a lot of other products out there that will send a flurry of SNMP packets. And I think we've all heard about the days when you could set an old copy of HP OpenView and actually do a denial of service attack on your own network. So we've made it so that this is going to automatically collect all this information, yet we're going to do it in a very controlled fashion. So what we do is we spin up one thread per device. So let's say you have that Cisco Nexus switch out there. We have one thread that talks to that. You're never going to hit it with multiple packets. So one packet goes out and we say, give me these 25 OIDs about this one interface. We collect all of that interface information, bring it back, and once we get that, we then collect the next interface and the next interface. So we're not flooding the network, we're just doing one packet out, one packet back, one packet out, one packet back. We have 5 minutes to collect this information. Collecting all the interfaces off of a 500 port switch, you can do that in 5 minutes. That's easy to do. And it's just going to be a trickle of data back and forth because it's sensibly collected. This is how we can support some very large network infrastructures.
Yeah, how does that work when you have 1,000 nodes in the network
So
from the server perspective?
So we can control how many threads we start and say, okay, we will start, and if let's say you say 250 threads. You start collecting the first 250 devices. Once we finish talking to a device and we say, okay, you've got 3 interfaces, great, we got that off the router. We're going to start another thread, talk to another device. So again, you can control how many simultaneous threads you want to talk to network devices. And we finish a bunch of devices, we'll just start a new thread. Again, 5 minutes is a huge amount of collection period if you're collecting in a slow and controlled manner.
And then we're also seeing a lot of some of the device manufacturers themselves going to telemetry into their own tools. Is telemetry something that's kind of where you're wanting to go as well, to kind of take from the device?
We've been watching some of that. Part of the problem is that the telemetry that they have these days is still, I'm going to say, a lot less information than what you get out of just SNMP. I mean, SNMP has been around for near 20 years now, and there's so much rich information that has been built there, sitting there, not unused. until you go in and say, hey, I have to find out why we're dropping packets and where we're dropping packets. But the telemetry is really kind of at the early stages these days where you're not getting the depth of error counters, not getting the depth of QoS information. So I would suspect in another 2-3 years, the telemetry will grow to cover some of that, and it will get better. And that's on our roadmap, but it's something we're kind of waiting for the vendors to be able to do.
I think you mentioned it earlier, but what about the MIBs for all the different devices and different manufacturers?
That's something we've automated.
Yep.
So I guess I'll answer that question really quick. So if you have a Cisco Nexus, they actually have different MIB support than an iOS or even iOS XE or ASA. So all of those are different boxes. What we have is we have a way of asking the device, what are you? And then figure, okay, these are the MIBs that we believe it should support, and we test those MIBs to say, does it actually provide us with data? Therefore, we know what to get off the box. So it's a bit of an introductory process when we start up. We find out what are these devices capable of doing, what information can they get us, and then we pull the information. If we find a box that says, let's say this is some really old 3Com hub, we'll go talk to it and say, okay, you're not looking like anything else, then we'll just give it a default and say, these are the things we're going to try and pull off of it by default. If we get good stats, great. If we don't, it just doesn't support it.
Yeah. But if I have like an obscure box somewhere that has its own MIBs, is that something I can load into the system, or is that something that you would
you can put custom MIBs in if you want.
Sorry, do you have any plans to support YANG-based telemetry and use different transport mechanisms such as gRPC?
So actually, on another show, I ended up just doing an interview just a week ago today on NetConf, RESTConf, and Yang. So we're looking at it. So far, we haven't found enough penetration to be able to develop against it, but we're definitely watching it closely because I figure that's definitely going to be the next iteration of what happens to network equipment.